What's up, guys? So today we're going to be doing a video on synthetic substitution, which is really just another way of saying synthetic division. It's an application of synthetic division which allows us to plug numbers into a polynomial and evaluate the polynomial the same way that you could take this 3 and plug it into this polynomial and get an answer. We can use synthetic division to do that for us. It might be a little bit faster. It might be a little easier, especially when you have longer polynomials with higher powers. So let's just see how that works. So we're going to take the 3. We're going to plug the 3 in to the polynomial. So we're going to write that in the box in the top left corner of our synthetic division problem. Now remember, with synthetic division, we changed the sign. But that's because we were dividing by a binomial, like for example, x minus 3. And if I was dividing this polynomial by x minus 3, what you plug in is the number that would give you 0. And remember, I told you that was going to be important later. Well, this is why. Because here you're plugging in that number. That number that would go here, that's what we're plugging in. So we don't change the sign. We plug in the 3. Now we bring down the coefficients. And notice it goes from x to the third to x. So the squared term is missing, which means we need to put a 0 in for that. And then we continue on, -3 and 5. And we're just going to do the synthetic division. Bring down the 2. 2 times 3 is 6. 0 plus 6 is 6. 3 times 6 is 18. Add these together, you get 15. 3 times 15 is 45. And that leaves us with a remainder of 50. That remainder, as it turns out, and this is pretty cool, this is the same thing you would get if you evaluated f of 3. And if you don't believe me, let's do it right now to prove it. So let's plug in 3 and see what we get. Okay, and we're just going to work this out. So we got to do the exponent first. 3 to the third is 27 times 2, that's 54, minus 9 plus 5. And if we combine all of these terms, you may notice already, you're going to get 50. So synthetic substitution is a way to do evaluation of a function. When you plug a number into synthetic division like this, the number that you put here, the remainder at the end is what you get when you plug that number into a polynomial. And this is going to be used again when we start calculating zeros and we start factoring polynomials in a later unit. So another problem you might be asked to do related to synthetic substitution would be to sort of work backwards, as you see in this problem. It says to find k if 2x squared plus kx plus 7 divided by x plus 1 has a remainder of 4. So it's synthetic division, but it's like they've done it already and figured out what the remainder is. You've got to work backwards to figure out what k has to be so that you would get that remainder. So let's just write it out the way you would normally write out a synthetic division problem. What will we put in the box? Because that is a binomial, you have to plug in the opposite sign. And then we're going to use the coefficients however they're written. Notice there's no zeros that we need to skip. So we're going to say 2, k, and 7. And unlike usually, we know what the remainder is already. It's 4. So let's work this out as far as we can. You can bring the 2 down. You can multiply the 2 times -1 and get a -2. But now I've got to do k minus 2. And I don't really want to write out an expression down here, so let me skip ahead to the end and kind of work backwards. 7 plus something gives me 4. What would that something have to be? This would have to be a -3. 7 minus 3 would give me 4. Okay, well if that was a -3, what would have gone here? Again, working backwards. -1 times something gives me -3. This must be +3. Okay, again, working backwards. K and -2 add up to make 3. So what must k be? K must equal 5. You can verify this. Let's cross this out and put a 5 here. Bring the 2 down. Negative 1 times 2 is negative 2. 5 minus 2 is 3. Or 5 plus negative 2 is 3. Negative 1 times 3 is negative 3. And 7 plus negative 3 is 4. So it works out. That means k actually was 5.